in the figure, DE is parallel to BC. Find EC. So we have triangle ABC and DE is parallel to BC. Hence we can say AD over DB equal to AE over EC. So we have AD over DB equal to AE over EC. To put the values, you have 1.5 over DB is 3, AE is 1, and EC I will take it as X because we need to know that. So when we cross multiply, I get 1.5x equal to 3 into 1. So X equal to 3 over 1.5. So X equal to 3, 15 into 10. So this is 2. So we get our EC equal to 2 centimeter. Here again in this triangle ABC, we have DE parallel to BC. Now if DE is parallel to BC, this is parallel here, we can say AD over DB equal to AE over EC. So AD over DB equal to AE over EC. AD we don't know, that is X. DB is 7.2, AE 1.8, and EC 5.4. So the X will be 1.8 into 7.2 over 5.4. So 1.8, for to remove the decimal I put into 10. For 7.2 remove decimal I put over 10, and here we have 5.4. To remove the decimal I put 10 up here, and when you calculate this you get your answer at 2.4 centimeter. So EC equal to 2.4 centimeter. E and F are points on sides PQ and PR respectively of a triangle PQR. For each of the following, state whether EF is parallel to QR. Now in the first case, PE is given as 3.9, EQ is 3.6, now FR is 2.4 and PF is 3.6. We must show is EF parallel to RQ. So for that, first we will find the ratio of PE over EQ. So PE over EQ equal to 3.9 over 3. Here's a little correction, EQ is 3. PF is 3.6 and FR is 2.4. So here I will get 3.9 over, this is over 3, which is 39 over 3 and 13. Now we need to find the other ratio, PF over FR. So we have PF over FR. PF is 3.6 and FR is 2.4, so that is 36 over 24. If you divide it by 12, you get 3 over 2. So thus we see that PE over EQ is not equal to PF over FR. Therefore, by converse, we can say EF is not parallel to QR. So these are not parallel lines. Now for the second case, the PE is given 4 centimeters, QE is 4.5, PF is 8 centimeters and RF is 9 centimeters. We need to check if the lines are parallel. So first we will find the ratio of PE over EQ. So we have PE over EQ is 4 over 4.5. To remove the decimal, I'll get 40 over 45, and this is 8 over 9. Now on the other side we have to find PF over FR. So PF over FR, which is 8 over 9. So we see that PE over EQ is equal to PF over FR. So we can say that EF divides the sides PQ and PR in the same ratio. So by converse of BPT, EF is parallel to QR. PQ is 1.28. So just write here, PQ is 1.28. Now remember, they have given us the entire length is 1.28. PR is 2.56. So I'll just write this. This is the full PR is 2.56. So right here PR is 2.56 centimeter. This also is centimeter. Now PE is 0.18. So this is PE. Let's put it a little thicker. And PE is 0.18. Now we know PQ and we know PE. So we can now definitely find out QE. To find out EQ will be PQ minus PE. So PQ is 1.28 minus PE is 0.18, and that will be equal to 1.10. Now on the other side, here PR is given at 2.56 and PF, this is PF here, is given as 0.36. So we need now to find out FR, and FR will be equal to PR minus PF, that is 2.56 minus 0.36, which is equal to 2.20. Now to go back to the sum, now we know that PE is 0.18, EQ we have found out as 1.10, and on the other side FR we found as 2.20 and PF is 0.36. Now we can now go ahead and find the ratios. First let us find the ratios of PE over EQ. So we have PE over EQ 0.18 over 1.10. If you remove the decimals, you'll get 18 over 110. Reduce it, 9 over 55. On the other side, we need to find ratio of PF over FR. So we have PF over FR. PF is 0.36 over 2.20, which is 36 over 220. And this also, when you reduce, you get 9 over 55. So thus we see that PE over EQ is equal to PF over FR. So points E and F divide PQ and PR in the same ratio. So by converse of BPT, we can say EF is parallel to QR. In the figure 6.18, LM is parallel to CM and LN is parallel to CD. We need to prove AM over AB equal to AN over AD. So we'll take up the first LM parallel to CB. So here is LM and it is parallel to CB. Therefore, in the triangle ABC, I can write AM over MB equal to AL over LC. So in triangle ABC, it is given to us ML is parallel to BC. So I will write AM over MB equal to AL over LC, and this is by BPT. Now for the next part is given LN is parallel to CD. So we are going to consider triangle ACD, and in this triangle it is given to us LN is parallel to CD. So we will use BPT here. So when we use BPT, we will see AN over ND will be equal to here AL over LC. So AN over ND equal to AL over LC, BPT. So in the first one, we proved AM. We proved AM equal to M over MB equal to AL over LC. And in the second, we have proved AN over ND equal to AL over LC. So if you notice here, our AL over LC is common. So on comparing both, on comparing 1 and 2, we can say now AM over MB equal to AN over ND. But we still haven't got what we need. It was given to us AM over AB equal to AN over AD. So this is what we got. Now we'll just reverse the ratios. Let's call invertendo. So and we get MB over AM equal to ND over AN. To this we will add 1 on both the sides. So when we add 1 on both the sides, we get MB over AM, and this was given to us ND over AN. So we do plus 1 and plus 1. We take the LCM, so we have AM, so we have MB plus AM, and here the LCM AN, ND plus AN. And if you look up in the figure, MB over plus AM is AB, and ND plus AN is AD. So we have now AM over AB equal to AN over AD, proved. In figure 6.19, DE is parallel to AC and DF is parallel to AE. Prove that BF over FE equal to BE over EC. So the first part, DE parallel to AC, let's mark that in our figure. We have DE parallel to AC. So hence we have to take the triangle BAC this triangle BAC, and these lines are given parallel. It's given to us these two lines are parallel. So the points D and E divide AB and BC proportionally. So we have to say BD over DA equal to BE over EC. It was given to us DE parallel to AC. Therefore, we'll write BD over DA equal to BE over EC by BPT. We write this as equation 1. Now we'll take up this triangle. Here we'll take up ABE, and in this ABE it is given to us that DF is parallel to AE. So the points D and F divide AB and BE proportionally. So now we are taking triangle ABE, and it is given to us DF is parallel to AE. This is given, that this is parallel is given. So we can say now BD over DA is equal to BF over FE by BPT, equation 2. In the earlier we have proved that BD over DA equal to BE over EC. This is by 1. We proved it earlier. Now when we compare both these ratios, we see that BD over DA is common. So now I can write that BF over FE equal to BE over EC. This is by 1 and 2. And this was what was asked to be proved. So we have proved. To go over the sum again, in the first statement you have proved BD over DA equal to BE over EC. And in the next part then you proved that again BD over DA, but now it was equal to BF over FE. So hence when you compare both, since BD over DA was common, when you compare both you got BE, the yellow, that is BE over EC was equal to BF over FE. That BD DA came common. DE is parallel to OQ. So we mark that. So we have DE parallel to OQ. And if that is the case, then I can say that PE over EQ will be equal to PD over DO, because these two are parallel. So in triangle POQ, it is given to us that ED is parallel to OQ, and using BPT I will write PE over EQ is equal to PD over DO. This is equation 1, and this is by BPT. Now let me take the other part. DF parallel to OR. So we'll mark this. Here we have DF and it is parallel to OR. So which means now that PF over FR, so I'll write that, will be PF over FR will be equal to PD over DO. So this is equal to PD over DO. Now this we got in triangle POR with DF parallel to OR. This is equation 2 by BPT. If you observe both of them, you find something common, and that is PDDO here, PDDO here, which means now I can say that PE over EQ is equal to PD over DO. This is from 1 and 2. So earlier we have now proved that PE over EQ, so I'll write that PE over EQ is equal to PF over FR. PF over FR. So if these are equal, definitely you'll agree, we can use converse of PPT. You will agree that EF must be parallel to QR. So therefore I'll write EF parallel to QR by converse of PPT. To summarize this sum, first we proved that PE over EQ is equal to PD over DO. And then in the next part we proved that PF over FR was equal to PD over DO. And if you notice here, PD DO came common. This is what we proved for the yellow. P over EQ equal to PD over DO. And on the other side, we proved PF over FR equal to PD over DO. Now this was common. Have you seen this part is common for both? This is common for both. So now I can write that PE over EQ equal to PF over FR, and we have proved it. And these are if these are equal, if these ratios are equal, therefore the lines must be parallel. So now we got PE over EQ equal to PF over FR. So definitely agree the lines EF and EQ must be parallel. By converse of PPT, they must be parallel, because we prove PE over EQ is the same ratio as PF over FR. In figure 6.21, A, B, C are points on OP, OQ and OR respectively, such that AB is parallel to PQ, AC parallel to PR. Show that BC is parallel to QR. We'll first take up AB parallel to PQ. So we mark that. We have AB parallel to PQ. Now if AB is parallel to PQ, I can say OA over AP equal to OB over OQ. So for this was AB parallel to PQ. So I'm going to write OA, then mark it again, OA over AP equal to OB over BQ. So OA over AP equal to OB over BQ by BPT, equation 1. Now we'll take up AC parallel to PR. So here we have AC parallel to PR. So I can now write that OA over AP is equal to OC over CR. These are the 2 points that divide OP and OR in the same ratio. In the blue triangle, OPR, AC parallel to PR. So now I'm going to write here OA over PA equal to OC over CR. And that too is by BPT. When you look at 1 and 2, you see something is common, and that is OA and AP. OA, AP. So by comparing both, now I can see that OB over BQ is equal to OC over CR. This is from 1 and 2. So this is what we have proved. Let's just darken it in the figure and see what it means. OB over BQ. So here's OB over BQ is equal to OC over CR. So that means B and C divide these sides in the same ratio. Hence I can conclude by converse of BPT that BC must be parallel to CR. So I can say therefore B and C divide OQ and OR in the same ratio. So by converse of BPT, I can say BC is parallel to QR. So for this sum, what we did first we said AR over AP equal to OB over BQ. Then from the other information, we said OA over AP is equal to OC over CR. On comparing both these were common. This was common for both. So we take away the common. So we get now we get OB over BQ equal to OC over CR. So these C and B divide the sides proportionally. So I can conclude that BC must be parallel to QR. Prove that a line drawn through the midpoint of one side of a triangle and parallel to another side bisects the third side. So first we have a triangle, say given a triangle ABC. The next part says a line drawn through the midpoint of one side of a triangle. So here we are going to take D as a midpoint of AB. So we'll write here D is midpoint of AB. The next part says a line drawn parallel to this. So here is our parallel line. This DE is a parallel line. So we write that too. We mark this line as L. So L passes through to D and L is parallel to BC. Now what we need to prove is this part. It bisects the third side. So to prove it bisects means it cuts the third side into two equal parts. In other words, we have to show that this E is a midpoint. E is midpoint of AC. Let's begin with the proof. Now since L is parallel, so we start with the proof. We start with that L or DE is parallel to BC, and this is given. The minute we have line parallel, what comes to our mind is BPT. So I have these two points here. So I can say now AD over DB equal to AE over EC, and that's what I'm going to write, that AD over DB equal to AE over EC, and this is by BP T. It is also given to us that D is the midpoint. Now if D is midpoint, I can write that AD equal to DB. Reason, D is midpoint, which means now AD over DB equal to 1. This is equation 2. Earlier in equation 1, I have shown that AD over DB is equal to AE over EC. This was shown earlier because D was parallel, so I showed AD over DB equal to AE over EC. This was shown earlier. This is equation 1. But now I know AD over DB. This AD over DB here is equal to 1. So I'm going to write here 1 AE over EC. This was given to me here. AD over DB is equal to 1. So I have EC equal to AE. If EC is equal to AE, here EC is equal to AE, I can definitely say that E is the midpoint. So E is midpoint of AC. So L, line L, bisects AC at E, and we have proved. Just to go over the proof again, it was given to us this is parallel, DE is parallel to BC, and if DE is parallel to BC, I can say AD over DB equal to AE over EC. But then it was also given to us that AD is equal to DB. If AD equal to DB, therefore we should get also AE equal to EC. So E also becomes midpoint. Prove that the line joining the midpoints of any two sides of a triangle is parallel to the third side. So here we have got two midpoints. But D is one midpoint, E is the other midpoint. And now I join these midpoints by the line DE. I have to show, this is my question, I have to show that DE is parallel to BC. So here given is a triangle ABC. D is midpoint of AB. And on the other side, E is midpoint of AC. We need to prove that DE is parallel to BC. So the first part, I will say that AD is equal to DB, and the reason D is midpoint. And if that's the case, I can say AD over DB is equal to 1. This is equation 1. So next, I can say AE equal to EC, and the reason is E is midpoint. Of AC, that is given to me. So AE over EC is also equal to 1. This is equation 2. So earlier it was given to me that AD over DB equal to 1, and now I have proved AE over EC is also equal to 1. On comparing both these, I can say that AD over DB equal to AE over EC. Let me write this out what I have. I have now AD over DB equal to AE over EC. So D and E divide this D and E divide AB and AC in the same ratio. So hence I can use converse. So I can say that DE must be parallel to BC. So now I say D E divide AB and AC in the same ratio. So DE is parallel to BC by converse of BBT. ABCD is a trapezium in which AB is parallel to DC. The diagonals bisect at O. We need to show that AO over BO equal to CO over DO. To start this, we need to do a construction, and the construction is this EO. EO parallel to DC. So we write EO parallel to DC. Now we can use BPT here. Look up at the triangle ADC, this triangle, and we have this line that is parallel. EO, here this EO is parallel to DC. So we can now use BPT, which means these 2 points E and O divide the sides in equal ratios. So we take up triangle ADC. Here it was given to us EO is parallel to DC by construction. So using BPT, I'm going to write AE over ED is equal to AO over OC. So AE over DE equal to AO over OC. Equation 1 by BPT. Now for the second part, we saw that EO was parallel to DC, and because it's a trapezium, DC is also parallel to AB. So now we can say, we raise this, we can say EO is parallel to AB. So we'll write that EO parallel to DC, that was by construction. And we also know that DC is parallel to AB. Why? Because ABCD is a trapezium. This is the parallel sides of the trapezium. Therefore, I can say EO parallel to AB, which means now I can use my BPT here. If I take up the triangle DABO, I can use BPT. So I'll take up triangle DAB, and I know EO is parallel to AB, which means I can say now these two sides, these 2 points divide the sides proportionally. In other words, DE over EA equal to DO over OB. DO EA equal to DO over OB. This is equation 2 by BPT. We'll just reverse this, and on reversing we will get EA over DE equal to OB over OD. But earlier we have proved by equation 1 that AE over ED equal to AO over OC. This is by equation 1, and we call this by this equation 2. So comparing both the equation, we see this is common for both AE over DE, AE over DE. So by comparing both, I can say now OB over OD equal to AO over OC. And by cross multiplying, I get OB, I'll take OA down, and that OD will go up, so OD over OC. And I have proved. So in this sum, basically what have we done? First we proved AE over ED equal to BO over DO. And we also showed that DE over EA is equal to CO over OA. Now what was common for both? This part was common, and so we erased it. This is common for both, and hence we got now here we got OA over OC equal to OB over OD. So we got here OA over OC was equal to OB over OD. The diagonals of a quadrilateral ABCD intersect each other such that AO over BO equal to CO over DO. Show that ABCD is a trapezium. So given to us this some quadrilateral ABCD, and in this quadrilaterals the diagonals bisect at O. So diagonals BD and AC bisect at O, and also is given to us that AO over BO is equal to CO over DO. We need to prove that ABCD is a trapezium. In other words, we have to show that AB is parallel to DC. Here we do a construction, that is EO, construction EO parallel to DC. So if I do now EO parallel to DC, I can now use BPT. So I can say that AE over ED equal to AO over OC. So in triangle ADC, we had EO parallel to DC by construction. So now I will write AE over DE equal to AO over CO by BPT, equation 1. Now we already showed AE over ED equal to AO over OC by BPT, so I'll write that AE over ED equal to AO over OC. That was my equation 1. And it is also given to me that AO over CO is given AO over not CO over BO is equal to CO over DO. Now I'm just going to crisscross. I'm going to cross multiply these two terms, so I'll get AO and I'll bring CO down equal to BO over ODO. So what I've done, I brought this down here and I've taken this up here. So now we compare these two ratios. One ratio was AE over ED equal to AO over OC. And now I have yet another ratio, that is AO over OC equal to BO over OD. Now this is common. So when I compare both, I can say AE over ED is equal to BO over DO. Let me mark this in the figure. So here it's given AE over ED is equal to BO over OD, which means this O and E divide AB and AD in the same ratio. And if they divide in the same ratio, I can say EO must be parallel to AB. So I write that. Therefore, we can say EO divide AD and BD in the same ratio, which means that EO is parallel to AB. This is by converse of BPT. But earlier we know, or we have constructed EO parallel to DC. So when I compare both these now, I can say AB is parallel to DC. And if AB is parallel to DC, therefore ABCD is a trapezium. So I proved that ABCD is a trapezium. I proved the opposite sides are parallel. Here we have proved AB parallel to DC. So ABCD is a trapezium.